Hey everyone, so this is the last exercise from chapter 6F. I'm going to go through this one in much the same way as I went through the other ones. So I'm going to start off by looking at the transformations for this function. So we can see that the number in front of the sine is just 1, meaning that the amplitude is equal to 1. Okay. We also need to calculate the period of this function. So for the period of a sine function, we go 2 pi on n. There's nothing in front of the x in this case, or there is a 1 in front of it, so that means that that's going to be 2 pi over 1, which just simplifies to 2 pi, which is pretty nice, considering that our graph has to be sketched from 0 to 2 pi. Now we can also see that it has this minus pi on 3 here, which means it's moved pi on 3 units to the right. And hence why I've chosen to draw my graph starting, or going up by lots of pi on 3 and going up to 7 pi on 3. So it should be saying here it's a sine function, meaning that it starts at the origin, but it's moved pi on 3 to the right. So that's where it's going to start. We know it's going to end 2 pi units later, which is at 7 pi on 3. Okay, pi on 3 plus 2 pi is 7 pi on 3. Also, because it's a sine function, we know that it's going to pass back through the axis exactly halfway along, so it's going to be going up here, it's going to come down and then back up, and so it's going to pass through again at 4 pi on 3. We also know that our maximum should occur halfway between these 2 points, so it's going to be about there. And the minimum should occur halfway between these 2 points, which would put it down about here. This is a bit of an interesting one because we are sketching from 0 to 2 pi, so it would be a good idea to calculate the y-intercept, or know when x is equal to 0, because we're going to get some point down here somewhere. We can see that just based on the shape of the graph, but I'm going to do the calculation anyway, so I'm going to sub that 0 in. F of 0 is sine of negative pi on 3. Now negative pi on 3, that puts it back in the 4th quadrant, so that there is negative pi on 3. And from the symmetry of this, we should be able to see, well, it's the y value is being made negative, so that is the equivalent of negative sine of the basic angle of pi on 3. And if you know your exact values, then you know that that's the same as root 3 on 2. It's a good idea if we have some idea of how much root 3 is, so it's about 1.73. If we divide that by 2, then we're going to get about 0.85, 0.86, somewhere around there. So it's negative 0.86-ish, which, well, it's probably going to go about there somewhere. Okay, and again, because this has a period of 2 pi units, we know that when we go 2 pi on from here, so we come across here to 2 pi, it's going to have that same value of negative 0.86. If it'll let me actually show. Alright, these are the endpoints of the graph, so it's really important to have these. They should be labelled as well, and I'll do that shortly, but to start with, I'm just going to sketch the curve. I'm going to sketch it from where it sort of starts normally, so goes up like that, back down through here to the end point, and I'll just finish it off with this section out here. So I should label this endpoint, that's 2 pi and negative root 3 on 2, and likewise over here we've got the point 0 and negative root 3 on 2. Okay, using exact values. Technically should be labeling these x-intercepts as well in the same way, using their coordinates, but well, that's something for later perhaps. Anyway, that's the example. So that was a bit of a strange horizontal translation, a little bit different to the other ones. It hasn't worked out quite as nicely, but you can see that there's a definite process there. Okay, you sketch sort of the basic curve, and then we sort out any other y-intercepts or x-intercepts as we need to do. Anyway, we'll leave it there and move on to the next exercise. I'll see you all later.